definitely let me know. We're going to start right now with finding arc measures. So our lesson objective, of course, as you all know, we're going to start there. So in about 15-20 minutes, I'm going to ask you, do you feel like you can do this? Right? Because I want students will be able to find arc measures, which of course is the title. Find arc measures. And I want you to be able to identify congruent arcs. And that's it. So we have what's called a central angle. And a central angle always starts from the center and then it intersects an arc. So the central angle of a circle is an angle whose vertex is the center of the circle. This is ACB, angle ACB in the diagram below. Okay? Now, the angle also means that both sides are radii. So that is the plural of radius, and that means from the center to the outside and the center to the outside right there. Now, here's the thing, and this is notation. You just have to learn to write it properly and read it properly. If the measure of ACB is less than 180, okay, which you can tell it's small, then the points on circle C that lie in the interior of ACB, and interior means inside here, they form what's called a minor arc with endpoints A and B. So my minor arc, I'm going to make blue. This is my minor arc. It just means less than 180. The endpoints that do not lie on the minor arc, AB, form what we call major arc. So think big and little, right, with endpoints A and B. So our major arc, I'm going to do in red. And major arc means all the rest of it. So hopefully this makes sense to you. We've got a big one, the major, a small one, the minor. Okay? Now, sometimes it's directly in the middle. And if it's directly in the middle, then that's called a semicircle, which means half semi. Semicircle is an arc with endpoints that are the diameter. So I'm going to make diameter green. Okay, and that would be, say, for instance, see how AD is a diameter going through the middle? So this arc, halfway, or this one, is exactly a semicircle. Okay, so those are just definitions. That's what we call them. The small one's a minor, the big one's a major, halfway is a semicircle. Okay, now notation. Minor arcs are named by their endpoints. So it looks like this. AB, that's the blue one, and you put a little curve over it, meaning it's an arc. So instead of segments, it's the minor one, blue. Now, major arcs and semicircles, because you want to know you got to go all the way around the back side, so you're going to use the endpoints and a point, which means if I want to do the red arc, it's A, D, B. So in this case, it matters, like you can't do A, B, D, because that would mean the green one. A, B, D is the green one. That's why the color coding will really help you. Okay, but the red one has to be from A through D, ending in B. So hopefully all that makes sense to you. That's just naming stuff. So major, minor, and semicircles. Now, measuring them. If you recall, the measure of an entire circle is 360 degrees. And we're going to use that to figure out each one's. So the measure of a minor arc is the measure of its central angle. Okay, in this case, let's say I tell you that this is 50 degrees. Okay, then the minor arc AB is equal to 50. That's all it is. And that's the one that intersects it right there. So that means that AB, wait, small is blue, right? So this is also 50. It's just the measure of the central angle. Now the measure of the major arc, okay, is going to be all the rest. So the major arc being red is 360 minus 50. So it'll be 360 minus 50. So ADB is equal to 310. So that's red, that's blue. And then the measure of a semicircle is always the same. It's just half. So it's always 180 degrees, semicircle. And that would be like, say, from A to D. So all semicircles are 180. Hopefully that makes sense to you. Okay, I'm going to move this up just a little bit. Okay, so I'm going to do 3 little examples here. Find the measure of each arc, where RT is the diameter. Okay, so if I want to know RS, that's right here. RS has 2 radii that are intersecting that arc, which means RS is 110. Oh, it's not degrees because it's a length. Okay. Now the other one, RTS, is going to start at R, go through T, and go all the way around S, which I can tell will be a major arc. So that one is going to be 360 minus 110, which is 250. And then finally, we have this one here, which is RST, which is this direction. And since you know RT is a diameter, okay, then that is going to be 180. There you go. That's all it is. All right. Any questions so far? Raise your hand, because I can see your hands. Okay. Adjacent arcs. 2 arcs of the same circle when they intersect at exactly 1 point. So adjacent means right next to each other, right? Meaning RS and ST are adjacent. Okay, so RS is adjacent to ST. You could say that right next to each other. ST is adjacent to RT, those kind of things. So you have this addition postulate, which means that if you add 2 of them together, then it equals 1 big one. Okay, so the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So say I had AB plus BC, that's going to equal, so AB arc plus BC arc is equal to AC arc. Again, this is where your color coding will come in handy. Okay, it gives an extra little boost to your brain saying, how am I do this? Okay. So hopefully that makes sense to you also. It's just like segment postulates, segment addition postulates. Any questions? All right, we have just a little bit more to go over. But if you understand these concepts, then right now, if I asked you all, do you think you could find the arc measures and identify the ones that are the same? This is where I say, please respond, or I do a poll, or I ask you to give me thumbs up, or somebody at least unmutes themselves and says, yes, I think I can do that.
Yeah.
Thank you. Was that Faria?
Yeah. Bro.
Excellent. Thank you so much. Yay. Okay, a little bit of response. It's really hard for me sometimes to not be able to see you and hear you, so thank you. All right, so what we're going to do here is do a little more practice. So find the measure of each arc. All right, GE. So GE is this one here, right, plus this one here, because those are central. So GE is 120. Right? See how easy that is? Now we're going to do GEF. So GEF is this plus this plus this. So that's going to be 120 plus 110. So now I've got 230. Okay. And GF. Now, GF I can look at this way. So it's all of this not, right? So it's 360 minus 230 because it's everything it's not. So that one's going to be 130. See how easy that is? Which I love making this easy for you. Okay, we have a word problem. Literally, that's all this section's about. It's just finding those arcs. Okay, so you've all seen a circle graph. Here it is. Recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So who can tell me what AC is? A to C.
137.
Yes, it is. Thank you very much. Because it's 108 plus 29. Okay, I want a different volunteer. ACD. You're going to go all the way from here through here. So it's going to be that 137 plus 83, which is... I said different volunteer, but I know I want to do the notes a little quicker so that we can have more time to work. Sorry about that. Okay, ADC. Now, notice that the D is in between. So now you're looking at from here to here. You're going this direction. So it's going to be 83 plus 61 plus 79, and that is 223. And the measure of EBD is going to be from E through D all the way around. So for this one, since there's only one part of the piece that's not in there, I would do 360 minus 61. And I get 299. Again, if you have any questions about this, let me know now. Color coding helps, of course. Okay, we have two other little theorems, but they're very obvious, okay? Identifying congruent arcs and congruent circles. Two circles are congruent if and only if they have the same radii. Okay, so if AC is congruent to BD, then they're congruent circles. And that kind of should make sense because the definition of a circle is the radius. So you would write, okay, circle A is congruent to circle B if and only if AC segment is congruent to BD segment, which is pretty easy to follow. So that's you need either this to show that or this to show that. That's the definition. And all circles are similar. They're not all congruent, obviously. They'd be different shape, but they're They're all similar in shape, same shape, different sizes. So we have this little theorem that says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Since we define this and this by our central angles, if we know these two are congruent, then the arcs are congruent, right? So you could write that the measure of BC, or arc BC, is equal to the measure of DE if and only if angle BAC is congruent to angle DAE. Okay. And that, again, should sort of make sense to you. It is nothing that is tricky. Okay? Again, just a pause for a question if you have a question. Because all we really have left to do is look at a picture and do some examples here. Okay, so all I'm going to ask you to do is look at these and say whether the bold arcs are congruent. But the problem, of course, is that you can't tell what the bold arcs are. So I'm going to highlight them for you. This one here is a bold arc, and this one here is a bold arc. Are those congruent? Well, they both have central angles of 80, so yes. Because their central angles are congruent. Okay, now this one, the bold arcs, this one here, and this one here. I would say, well, are those congruent? Are they the same size and shape? And then you would say no. They do have the same central angle. So the arc is 90 degrees, but clearly this one's larger, right? TU is larger than RS. So they're what we call concentric, but they are not congruent. And last, the ones that are supposed to be bolded on here is UV and YZ. Are those congruent arcs?
Yes.
Absolutely yes. Thank you so much. And of course you would say yes, something like central angles are congruent. Okay. And that's about it. So if I asked you, again, going with the objectives, to find arc measures and identify congruent arcs, you feel like with these notes you will be successful in your assignment?
Yeah.
Thank you.